This is the second iteration of Dodepan, a portable musical instrument and MIDI controller that I've been working on and that I'm releasing as an open source project that other people can replicate. It's played by tapping on its 12 capacitive pads that produce different notes based on the current key and scale. There are 16 built-in scales to choose from, like major, minor, pentatonics, and a few exotic ones. You can tweak them or add more. The chromatic range spans from very low to very high-pitched sounds. One of the unique features of this instrument is that it's sensitive to tilting. Rolling it left or right bends the pitch, and pitching it up and down modulates the filter cutoff frequency. These effects can be disabled from a dedicated screen. Notes are affected by velocity, which means that gentle taps sound quieter and harder taps louder. This instrument has MIDI output functionality, so it can be connected to a music software on a computer or to another digital instrument to control them. Another new feature is the sequence looper, which can record and replay notes. It works together with a diatonic transfer selector, which transposes the recording around the current scale. The brain of the Dodepan is the Raspberry Pi Pico 2, an inexpensive microcontroller that provides the necessary processing power. It analyzes input from the capacitive touch sensor, reads and normalizes the accelerometer data, runs the direct digital synthesis engine, and streams the output audio to a digital to analog converter and power amplifier. The audio has higher quality compared to the first Dodepan, which had only 8-bit at less than half the sampling rate. There's an onboard 3-watt speaker and a jack socket, which provides an amplified output that's okay for headphones, but must be attenuated before being connected to sensitive equipment. The synth engine is PRA32U by Ryo Ishigaki. Its 46 instrument parameters can be adjusted from the instrument editing section. New instruments can be created and stored as user presets, which are preserved across reboots. Everything is powered by an 18650 battery, protected by a management module and recharged by a USB-C. Battery life is theoretically just under 20 hours. A warning icon pops up when the battery is low and you need to recharge it. I wrote the software in C and C++ with the Pico SDK and released it on a public repository. Those who want to use it might not need to compile the code or even understand it, since a single binary file is available and ready to be flashed onto the Pico, just like future firmware updates. I designed and 3D printed the enclosure and some custom parts, which are all available to download for free. That's right, Dodepan is not for sale, it's an open source project that makers and thinkers can recreate and build on top of. My instructions include a bill of materials, a schematic for circuit assembly, the 3D models and their source, and the production files to fabricate a PCB to hold all the components together. Those who do not wish to use the custom PCB will also find a version of the enclosure for the hand-wired circuit, and those who do not have access to a 3D printer might come up with creative ways to build an enclosure. By the way, the capacitive pads are simple drawing pins that I painted using nail polish. I want to encourage you to try building a Dodepan yourself and experiment with the code and the design to see where you can take it. Don't be afraid to try new things, and don't be discouraged if they don't work out at first. Engineering, design, and art are all iterative processes. You need to build on top of your mistakes to get better.